Well, it's just gone 22 minutes to 7 here on Classic 1027. That means time for tonight's Classic Business Panel. Now, 2 weeks ago, I hosted a very short discussion on licensing patents in the manufacturing and the sciences, and I felt I needed much more time to fully explore the ins and outs of it. So to talk about this and the commercialization of R&D, not only in public research institutions, but in manufacturing and science in general, it's a great pleasure to welcome back John McKnight, Spur and Fisher partner in patent licensing. John, great to have you back on the show.
Hi, Michael. Thanks very much for having me.
And in studio, Dr. Sean Oosthuizen, a chemical process engineer, researcher and inventor at the Council for Scientific and Industrial Research, the CSIR. Dr. Oosthuizen.
Hi, Michael. Thanks for having me back.
John, broadly speaking, when we look at this whole process of commercializing technology, which is so important to get South Africa growing again, and very often we find, I was just talking to Sam Soul about whether or not Sagamata will be the next African unicorn, but we need to find the next African unicorn to spur the kind of growth that we need in the South African economy. Broadly speaking, what does this process of commercializing technology entail?
So, Michael, if I may, I'd like to sort of contextualize our discussion this evening about intellectual property and just sort of put it into perspective as to what it is exactly that we're talking about. So, intellectual property protects the products of the intellect which are capable of commercial exploitation, and a lot of focus is on patents. But patents are only one of a species of intellectual property. So, if intellectual property is considered the genus, then the major species of intellectual property are patents, but we also have registered designs, we have copyright, we have trademarks, we have know-how. We have other species of intellectual property as well, but those are the big five. Those are the most common. And when we look to commercialize those, we must think of it in terms of property just as your house or your car is property. So if you have a flat or if you have a car, you can live in it yourself and in so doing sort of save money by not paying anybody else to use that property. And just like you can rent out your flat or your car, you can rent out patents and designs and copyright and trademark. You can allow other people to use them, and in return you get a royalty fee. You can sell them outright, just like you can sell a house or a flat, and you can assign intellectual property to third parties. But there are other ways, just like it can be, one can do with property, that you can commercialize your intellectual property. Now, there's a distinction between exploitation of the intellectual property that you own, and then there's monetization, where you actually try and turn it into cash. You try and turn it into money. And there's 8 sort of real models that work around a monetization of intellectual property. And when we talk about licensing intellectual property or assigning intellectual property, it's usually a bundle of rights. And I know Dr. Oosthuizen will talk about this in greater detail when we go into the fantastic work that he's been doing in the production of titanium powders and the like. But you should always remember that it's patents and it's know-how, and there's normally copyright in there as well, because there's often software which goes around process development and process maintenance and things like that. So it's a whole bundle of rights that we are looking to monetize, to get cash. And we can do that either through using it ourselves, through commercialization, through outright sale, through licensing. There's also the concept of securitization, or using it as collateral, just so you can use your house or your car to raise money through a loan or through structuring future royalties. There are tax implications which are behind that, and then of course there's spin-outs and joint ventures where you can throw your intellectual property in the pot with another party who's working on similar technology, and together you can all start pulling in the same direction. So there's a lot of options available to an intellectual property rights holder, especially considering that there's normally a package deal around the technology.
Absolutely, and I think you've really introed the subject quite nicely there, John. If there is a route to market to commercialize, there are many ways to get to one's end destination. It's a question of exactly how you want to get there. Now, Dr. Oosthuizen, at the CSIR, technology transfer is a big thing. and it's a word that's bandied about, but I just want to get an understanding, a good grasp of what technology transfer really means.
Oh, I wish I could clarify that in the time we have. Now, firstly, let's put things into perspective a little bit. A patent can be conceptualized as being a business tool. And it's easier to obtain a weak patent than to profit from a patent. And when you are doing technology transfer, there's a whole lot of other things that come into play. There's a weakness in the innovation or commercialization chain called the innovation chasm. And this generally refers to the inability of breakthroughs in research to reach the market as products and services. There's specifically a difficulty for new technologies to make the transition between being applied by so-called visionaries or early adopters and pragmatists, the early majority. So this so-called chasm determines whether technology will reach mass adoption or not. So in the past decade, the Department of Science and Technology has put into place several instruments to help bridge this gap. One of them being the National Intellectual Property Management Office, NIPMA, which helps patents and strengthens our intellectual property rights, and also helps commercialization of those patents. And then the Technology Innovation Agency. Now, it's important that innovating companies choose a market and they understand the whole product concept, positioning the product, building a marketing strategy, and choosing the most appropriate distribution channels and pricing. So if we take, for example, the most active company in the IP scene, it is IBM, who for the past 25 years been the global leader in patent output. They generate about an income of $1 billion per annum from licensing their patents. But you must keep in mind that since 1993, IBM's generated more than 100,000 patents. And in 2017 alone, they've added another 9,000 to its portfolio. So such an incredible, vibrant patenting strategy is obviously not possible for even larger South African companies.
Yeah. But I think what you've demonstrated here is that one needs to consider how you partner, because you can be generating a lot of patents, but you don't have the capacity in-house to be able to take all of these brilliant new technologies and ideas to the commercialization stage. And so it's good to be able to identify third parties, entrepreneurs, new startups, or even existing industry players that you can collaborate with here. How does one go about doing that? Because it sounds easy when you just put it out like that, but finding the right partner must be quite a daunting process.
Well, in a sense, this is where the CSR can assist. We're mandated to conduct research and development to improve the quality of life of the citizens of South Africa, and we're also legally required to capture the results of this R&D as intellectual property. So we've got in-house offices. And I think, as John mentioned last time, having your R&D done at the CSR, you can qualify for tax credits, which can equal up to 150% of the expenditure incurred directly on your R&D. So we've built up expertise in setting up, say, pilot and demonstration plants, and we've got the expertise on handling chemicals and on-site utilities. So the CSR is, in a sense, an attempt to bridge the gap not only between our own research, but also between the early stage research of the partners that we collaborate with and final industry.
And it's quite exciting, this development that really has gained quite a bit of momentum over the last few years. John, just back to an earlier point, I mean, if you look at the broader suite of IP, and let's look at perhaps patent registration, as one of the genus that follow on from that. At what point on a particular research project does a researcher, now perhaps working at the CSIR, need to start thinking about, oh, wait a minute, I'm actually onto something here that should potentially be a game changer, and that might require patent registration? At what point on the research project should the researcher be thinking about this?
That's an excellent question, Michael, and the answer is as soon as possible. And the reason I say that is because one of the criteria in order to gain patent protection is that when you apply for your patent, it must be absolutely novel. In other words, the invention must never have been made available to the public prior to the date on which you apply for your patent. Now, the critical thing about that is that it's very easy to destroy your own novelty. For example, having a paper published, having a poster done at a presentation, or even presenting a paper at a conference. So certainly, before any of that kind of activity takes place, the researchers should be in contact with their TTO, if they have them, with their in-house patent IP resource, or failing that, with an external firm of attorneys to discuss the work that they're doing, and if they're about to make a public disclosure of it, be in any of these formats, whether it's advisable to get your patent application in before you make such a public disclosure. So the bottom line is, it's really important that that researchers are aware that they can shoot themselves in the foot, and that patent protection must be done as soon as possible, very early on in the process.
So if you have that eureka moment, for heaven's sake, don't go out and tweet it. Go and chat to your patent attorney first. Stay right there.
Quite right.
My guests tonight are John McKnight, Spur & Fisher, partner in patent licensing, and Dr. Sean Oosthuizen, chemical process engineer, researcher and inventor at the CSIR. We're talking patents and IP, and we just have to take a quick break from this panel on Classic Business, only on Classic 102.7. Well, welcome back to the panel. You're tuned in to Classic 102.7, and this is Classic Business with me, Michael Avery. Now, we're talking about commercializing IP with a specific focus on the great work being done over at the CSIR. And I've got what might seem like a simple question. So forgive me, John, but what actually qualifies as an invention? Because I can read about a scientific process, for example, but if I use that in a new or novel way, does that qualify, even if I didn't invent the process? I mean, I think to me it's a very interesting question, because we might think we've invented something new, but perhaps it isn't all that novel.
Well, that's a great question, Michael. So there are basically three major considerations for patentability. The first, as I've mentioned, is absolute novelty, right? So you have to have been the first guy to have thought of this particular concept, and it must be different from what's gone before. But that difference cannot be trivial or obvious, and you often hear patent attorneys talking about obviousness, because there might be a very small point of distinction over that which is known before, that which is called the prior art. So you've got to be novel over the prior art, and that point of novelty has to have some technical advantage. So if we can just go back to first principles, the whole reason one is granted a patent, which is effect a 20-year monopoly on the technology, it's a reward, it's an incentive to teach the population something that they didn't know before you came along, and in so doing solve a problem which had afflicted society. So we have patents for new pharmaceuticals, we have patents for processes for the production of titanium powder, we have patents for new improved mousetraps. But the thing that they have in common is that they have solved a problem which has afflicted society, be it a more efficient way to kill mice, or be it a more efficient way to produce crystalline titanium powder. So if you hit upon a solution to a problem which is novel and has a technical advantage, and no matter what field, you're almost certainly talking about patentable technology.
Right, so I can't just put a squiggle in a pen and say I've created a new kind of pen. I'm not really solving for any problems in that. Dr. Oosthuizen, you're presently scaling up that patented process for the production of titanium metal powder. We're the second largest producer of titanium mineral concentrate in the world, and we've got the fourth largest titanium mineral reserve. So we've got an awful lot of this stuff. What is the commercial opportunity here that you're seeking to exploit?
Michael, maybe I'll try an analogy, because jumping straight into titanium is it might be a bit confusing. So let's use aluminium, because it's more accessible to most people. So although aluminium makes about 8% of the Earth's crust, it's not found in its metallic form, similar to titanium. So aluminium metal was first created in a lab in about 1825 by heating aluminium chloride and potassium amalgam. And at this stage, aluminium was considered to be as precious as platinum. So in 1885, Napoleon III had this entire supply of French aluminium made for a French science exhibit melted down and pressed into cutlery. So there's a often repeated story that Napoleon was rumored to have eaten off the aluminium plates while his guests were made to eat off lowly gold. So, which is probably not true, but aluminium was considered so rare that in 1886 the Washington Monument was capped with what was then a large amount of aluminium, and that was a 3-kilogram pyramid of aluminium as a cap. So in 1886, an electrolytic process was discovered simultaneous on two sides of the Atlantic, which allowed mass production of the metal from its mineral, and that brought the price down from tens of thousands of rands per kilo to about 8 rands per kilo. I think everybody is now familiar with aluminium being used in everything from car engines to household items. Now, titanium is similarly abundant, and South Africa has a lot of the mineral. As you mentioned, we meet about 20% of the world's raw material demand for the production of titanium dioxide pigment. Now, the pigment itself goes into everything from white paint to sunscreen to toothpaste. However, the titanium metals industry is only about 200,000 tons per annum compared to millions of tons of the oxide pigment. Now, the reason for this low production rate of titanium metals is the fact that the industrial process being used for over 50 years now is a very difficult and energy-intensive process. Now, what we've been tasked with at the CSR is basically coming up with a novel process to produce titanium metal. And that is then our patents on titanium metal powder.
Now, what are the advantages of a titanium metal? We know aluminium is very light. I believe titanium is quite sort of spongy and light as well.
Well, titanium, when you produce it at the moment in the industrial processes, is a 10-ton chunk of metal that is then broken down and melted under vacuum twice, and that takes up to a month to get to final mold product. But titanium is only being used in about 5% of its potential applications. It's about half the density as steel, but as strong as steel. It has excellent resistance to corrosion. It stands up to seawater almost indefinitely. And it's also got a very unusual property of what is known as osseointegration. So you might know of titanium medical or dental implants. So the human bone cells or animal bone cells directly attach and grow on the surface of a titanium metal implant. So it's inert in the metal body, and it's actually accepted by the body. So titanium can and should, in my opinion, be used in a large amount of additional applications. You can imagine lightweight cars, trains, trucks.
Aerospace, that kind of thing.
Exactly.
So why isn't it? What are the challenges here? Is it just a proof of concept issue? How much does it cost to set up the metallurgical processing plant here to demonstrate the viability of commercial scale production of titanium?
Well, at the moment, a large-scale plant is about, I would say, 10,000 tons per annum, and they're being set up reasonably regularly. But at the moment, the process itself, the cost of the process itself, is such that the market is locked in. So titanium is considered at the moment an exotic material because of the way that it's produced. So to make titanium, you actually have to sacrifice another metal. At the moment, that metal is magnesium. So to produce titanium from its ore, you have to chlorinate it to produce a chemical called titanium tetrachloride. And you then react that with molten magnesium metal at 1,000 degrees centigrade. And this is a fairly expensive process. And then you end up with this 10-ton lump of titanium metal, which you have to break down and process. So what the CSR has done is we've developed a way of producing titanium metal directly as a powder. The benefit of this powder is that you don't have to machine it as much. You can directly use powder metallurgical processes, which means near-net shaped titanium parts, and also feeds into the increasing use of titanium powders, which is used in 3D metal printers, which can be used to manufacture aerospace parts and bespoke medical implants, and hopefully be taken up into more applications.
Are we close to commercializing this at a scale that will create new industry for the country?
That is the drive of the Titanium Centre of Competence that is sponsored by the Department of Science and Technology at the CSIR. This technology is, however, on the bleeding edge of innovation. It's not even cutting edge. So bridging the gap between this invention and industrialization, especially in the field of metallurgical processes, where the average time for adoption of a primary process can be up to 4 decades. It's challenging fast-tracking this. So it's a fairly challenging process to work on.
That said, though, are the funders there? Are the visionaries there with the deep pockets to back the program? Because what I'm seeing here is a fantastic opportunity for the country.
Definitely. We've had incredible support from the Department of Science and Technology. And increasingly, we are engaging the likes of the Industrial Development Corporation and other parties that I'm not at liberty to disclose.
Well, very exciting, and as you said, at the very bleeding edge. But I think in our discussion, I'm sure there were some lessons for listeners and entrepreneurs out there who would be interested in commercializing some of their R&D and partnering with the likes of the CSR and others. Thank you very much, Dr. Sean Oosterhuizen, chemical process engineer, researcher and inventor at the CSIR, and John McKnight, patent licensing expert and partner at Spur and Fisher. And that's all for tonight, folks. Stay tuned. We've got Glenn Lewington and Classic Silver Screen up next on Classic 102.7. Thank you for listening to Classic Business with me, Michael Avery, and a word of mention to my dearest mum, who turns, I'm not going to reveal her age, but happy birthday, Mum. Love you very much, and really wish you all the best over what's been a very trying time. Good night.